To prevent our cultivator from sinking into the ground, we can call the support function while attaching or detaching the machine. In our case, we will bring down our support collisions when detaching the cultivator and raise them again once we attach it. Let's add the support tag in Attachable and name the animation Move Support. Next, we need to prepare the animation. Let's create a comprehensive animations tag with an animation we call Move Support. Inside an animation, we want to move parts. We have previously configured the node IDs with the i3D mapping, so we can now control the specific indices. Let's take support left as node. Choose start time 0, which is the time in seconds when the animation starts, and end time 0.5, end of the animation after X seconds. Furthermore, we need to use start trans and end trans to specify the movement in world space, that is X, Y, and Z. Since our collision support left starts at the values 0, 0, 0, we move it down the y-axis by 0.385, which fits well after sufficient testing. Because of our good preparation, we can adopt the same values for support right. Let's save the XML and look at the animation in-game. While detaching, the outer collision will be moved down. While attaching, the animation is played backwards. Attention! Once the cultivator is detached, there is no collision at the top of the cultivator anymore. This can be prevented with an additional compound child collision. We don't add these in this tutorial, but would suggest to do it on your end in your mods. To allow our cultivator to fold at all, we need the foldable function first. Now, after adding it to the XML file, at least the help menu will show that we can fold the cultivator. Next, we need a folding configuration. This step is necessary because, for example, there may be multiple folding animations on other models. For example, for a silage trailer in the store, we can select that the left or right side could be folded up. The next sub-item is folding parts. Detaching limit allows detaching while driving, which we set to 0, which prohibits detaching while driving. Last, we need to require the appropriate animation from the animation tag and set the speed to 0.5. The value can be adjusted at your discretion to fine-tune it later. If it is 1, we could delete the parameter from the function because 1 is the default value. Once we have applied these settings, we can create our animation for folding. The bottom line is that we want to raise the foldable elements on the left and right. Let's create a new part with the node arm left with start and end time, as well as a start and end rotation. If we take a quick look at the animation in-game, we are able to find any errors and fix them on the fly. To avoid restarting the game for every change, we can open the console and type GS Vehicle Reload, which will update all attached devices of the vehicle that we're using directly in the game. Once we think the animation is running smoothly, we can move on to the corresponding hydraulic cylinders. To move other objects triggered by animations and set dependencies between them, we use moving tools and moving parts, with the moving parts themselves referenced in the moving tools. We've put a few transform groups in specific places within the model earlier, and we'll use them in our XML. We make sure to name them during the tutorial and have a look at them in Blender. We need to start with the cylindered function. Next, let's create moving tools and a moving tool with the node ID arm left. Depending on the animation we just created, we want arm left hydraulic and arm left part 01 to move. We create dependent parts for this. With this addition, our vehicle knows that depending on the movement of arm left, the other two elements should be updated as well. The exact movement can be defined in moving parts. Let's create a moving part with the node ID arm left hydraulic. It should be aligned to the reference point arm left hydraulic ref. Reference frame defines the Y rotation of the part, and reference point the X and Z rotation. Since there are many ways to point to a point with the Z-axis, the Y-axis must be fixed to the top. In this case, fortunately, it is the same point. Now we could briefly save, go back into the game, and have a look at what we've done so far in-game. So far, so good, but the piston does not move with it yet. We have to create a translating part with the node ID arm left hydraulic punch. We also have to make sure that the axis of the models fits to each other. In the Giant's editor, it is the Z-axis, which is dedicated for the movement direction. In Blender, it's different. Attention, it is the Y-axis, since Y and Z are known to be interchanged. For this case, we have added a small tool into the exporter. In the Tools tab, you will find Align Y-axis. This is the way it works. First, we have to select the object from which we want to change the origin of. If we press Shift and select another object with the left mouse button that is located in the direction we want the Y-axis to show, then we press the button for Align Y-axis, and our origin should point in the right direction via Orientation Local. Let's go back in game after exporting, update the machine with our console command, and have a look at the animation again. The hydraulic cylinder should reasonably follow the animation. Let's turn our attention to the front arm left part 01 that we just set as a dependency and create a moving part for it. Since we are now working with an additional lever, it gets a bit more difficult, but once you understand the logic behind it, the preparation also becomes very easy. Arm left part 01 is referenced to arm left part 02, which will be aligned to arm left part 02 ref again. The reference frame for arm left part 01 is arm left part 01 ref frame, after which our moving part will align. Furthermore, we have a dependent part, which is arm left part 02. For arm left part 02, we have to create another moving part with the reference point arm left part 02 ref and the reference frame arm left part 02 ref frame. The former is our target and the latter is the alignment. We save and test it again in-game. You can complete the rest in the same way. A possible walkthrough for self-checking can be found in the Blender file of the next chapter, part 10.blend.